Hello, and welcome back to the Fullerton College Pre-Press Print 75 and 77 combined lecture. This is Professor Ben Hewitt, and we're taking a look today at PIA's Pre-Press Trainee Manual, Section 3.3, Digital File Formats. This chapter is a little bit more in-depth on what to expect from different file types you'll encounter working in pre-press and the graphic arts industry. Analogy time, if section 1.3, the digital file basics, was an aircraft recognition spotting chart, this chapter section is a bit more like Jane's guides, where you have information a bit more about the different types of things you're looking at, as opposed to simple recognition and very basic assumptions. So we're going to take a look, hopefully in some good depth, about the different parts of these files, how they work, how they don't work sometimes, what to expect when you see one of these things show up in your email inbox from a client. That's what we're going to be about. I'm also going to show you either in this video or in a related separate video, which is increasingly likely as I mull that over in my mind, about what JPEG compression actually does, because I find it fascinating. Hopefully you will too. Let's move on and take a look at what we have for us this time. Again, we're looking at the different types of things, the different types of files. We're going to look at different file formats and their extensions. You want to be able to see that extension, the .jpg, .psd, .pdf, and know exactly what to expect based off those 3 letters after that period, sometimes 4 letters. And we're also going to look at the advantages of the PDF format. You'll notice it does not say advantages and disadvantages. It simply says advantages. That is not a typo, and that information is still correct a few years after this was originally published. Again, we've looked at this before, the question of pixel versus vector artwork. Are you looking at a grid of pixels, or are you looking at a mathematical series of lines and points that create a shape? Remember that pixel images, raster images as they're known in printing as well, they're built out of a grid of squares, and each square in that grid will vary on size. Actually, really, each square in the grid can be any size. And the size of the thing matters based off of how many of those you're allowing to be in an inch. So you want to know how big a pixel file is in actual real-world inches or centimeters? That answer can only be answered with another question, which is, well, how many of these squares do you want per inch or per centimeter? How big do you want to make the tiles determines how big you want to make the picture. It works like an old school mosaic or a new school mosaic. One of these days I'll put together a new slide for this with a picture of Justinian or one of the old Byzantine emperors, because there's a lot of mosaics of them. And it lets me pull in obscure-ish history, because you know I like that stuff. Meanwhile, vector graphics are simply points and lines and mathematical formulas that describe these things. They describe where things begin and where they end. And vector graphics are actually very, very, very similar to CAD graphics and drafting work. In fact, you can sometimes interchangeably, depending on the software, pull files from a CAD system straight into Illustrator. Not just talking about the plugins we use with Esco's CAD to add graphics, but I have found in the past that working with architects and people and some engineers who send print files, they'll create things in CAD and they will work fine in Illustrator because the mathematics are basically the same thing. In fact, Illustrator is a sloppy version of CAD. I know Illustrator feels, if you're just learning it and you've come from a Microsoft Paint, and I'm not saying like a bad thing, but if you come from a pixel-based drawing system and you come into vector graphics, it's gonna be very confusing, and it feels really rigid and conformed, and you're stuck following these rules that don't quite make sense. Well, let me tell you that is in fact the easy version of CAD, which is nowhere near what you see is what you get, and you have to do more of the math yourself and be aware of your positioning. Where's my mouse? Speaking of aware of positioning. Pixel images can express subtle changes in color. Pixels are great for showing photos because they can show you all sorts of details as a camera captures it of each individual little spot of what you're looking at. And so long as they are sufficiently small, your eyes can't tell the difference between the pixels, and to you it looks like an image. Of course, for the computer, it does not. I'm probably going to also include my favorite video about spreadsheets in this one. If you've seen it before and you're already a fan of Matt Taylor, you can just chuckle to yourself, oh, Ben's sharing that video again. If not, do give it a watch. He's good. He's entertaining. I like his books too. And it's a good point about the spreadsheet use and how imagery works on computers. Because to a computer, it's not a picture. You may see a picture of your best friend in a digital photograph, but to your computer, it's simply a series of numbers telling it where to put what color. Pixel images are also, they are size and resolution dependent, meaning that, again, how big it is depends on how many pixels you allow to exist per inch. You don't really have much of a chance to do a whole lot more with it. If you make it bigger, you can make it bigger, but you're not getting any more quality. That whole Blade Runner zoom enhance thing just doesn't work because the camera captures what it captures and then entropy happens. You make it bigger, you lose data. You try to compress it, you lose data. There's no way to add data to it. You only start with data and then it degenerates. Typically, they are much larger in file size. And the number of megabytes or kilobytes or gigabytes required to save a pixel file is more than a related image done in vector. As shown in this slide, they show an EPS versus a TIFF of a logo being built, presumably from Illustrator. And the vector version is less than a megabyte in size, but the pixel version of a printable sized file is closer to 9 megabytes. Vector is very efficient in file size, which is one of the things I like about it. I'm jumping ahead to vector because gosh, do I like vector. Anyways, we've looked so far at pixel and vector, but there's another category here as well that I've mentioned briefly in 1.3. They just throw it in there. And let me tell you that I really like this word. Not quite as much as I like the word spectrophotometer, which is my favorite word in all of printing. Also my favorite device. Those things are cool. But for those of you who don't know, a spectrophotometer is a measurement device that actually measures the physical wavelengths of light coming off of any object or any surface, telling you with mathematical precision, what color is this exactly? Down to very, very fine, unperceivable differences that the human eye cannot detect. It can tell you if two colors are the same or not. Gosh, I love those things. They're so much fun. Anyways, a metafile is my other favorite word because it's just so cool. Oh, it's meta. It's a metafile. It's not the file. It's above the file. It's greater than the file. It contains the files. And then it's actually being used accurately. A metafile contains other types of files within it. It can simultaneously have pixel data and vector data in the same file. Spoilers, PDFs are metafiles. I can't hold secrets. I'm really bad at these things. Don't ask me to surprise somebody. It's just not going to work out. Common metafiles. Again, the most common one, and this is no longer true. This is true for exams in the class. This is true if anyone goes for the PIA certification exam. You'll need to know this. But the encapsulated postscript, the EPS, is no longer the most common metafile. That is now the PDF. Thank you very much. It has overtaken it. But the EPS used to be it. It was the bee's knees, the cat's pajamas, and other things you say with a transatlantic accent. Anyways, so metafiles contain both pixel and vector data. So common forms of this involve the EPS, or using an EPS metafile involve using bitmaps with a clipping path. In fact, Photoshop native files are also, technically speaking, metafiles. They contain the pixel data of all the raster images that you're manipulating inside Photoshop, but they also contain the vector lines you've drawn using your pen tool. Because I know you guys have been practicing this to crop out backgrounds and remove things. That clipping path is vector information. Therefore, a PSD file is meta, technically speaking, although its primary concern is raster pixel data, but it does contain vector data as well.